Hey class, welcome back to week 7 here of remote learning. All right. Hopefully you guys had a chance to work on the homework and lesson from Tuesday, and that made sense. Again, right, if you had issues with that or having problems with technology, hopefully you can reach out to me and let me know. Today we're going to kind of switch gears a little bit and talk about simplifying radicals. All right. And hopefully you also had a chance to look at my post from yesterday. All right, we're going to have try to get a Google Meet review session going on Friday at 10:30 to kind of talk about this week so far and the last couple of weeks. Actually, just kind of just do a little review, a little high before the end of the school year here. So hopefully you can make it on Friday at 10:30 to do kind of like a review session / kind of wrap up the school year. But we are going to be learning the rest of this week and next week as well. We're just kind of finish off the school year like that. All right, so today we're going to be talking about simplifying radicals. All right, and this is day 1 of it. And then on Friday, we're going to do day 2, but hopefully that'll be like our in-person during our Google Meet time. All right, and if you're not able to make that Google Meet for whatever reason, and then you will have to watch that Edpuzzle video then to kind of go over what we're going to do in the Google Meets. All right, so today, again, print out these notes if you can. Otherwise, take out a sheet of paper and write down all these example problems that we're going to do together here. Okay. So first, I want you to kind of do these first 3 problems here. All right. And you can definitely use a calculator for these problems. All right. I want you to simplify each of these radical expressions. All right. So number 1, we have the square root of 36. Number 2, the square root of 81. And number 3 is the square root of 100. All right, so either use a calculator or use what you remember or recall about square roots, and let's see what you get. All right, so, like I said, you can use a calculator for these. So I'm going to pull up my just basic calculator here, right? So the square root of 36, right? Hopefully you got is just 6. All right, and the square root of 81, hopefully you got as 9, and then the square root of 100, right, should be just 10. All right, so hopefully you got those answers, right? We've done square roots before. You've seen them last year in the previous math classes, all right? And so these numbers here, that 36, 81, 100, those are known as perfect square numbers, all right? And those are numbers whose square roots are integers or whole numbers, right? So just like square root of 36 was 6, square root of 81 was 9, square root of 100 are 10, right? These are all integers or whole numbers, all right? Which means that 36, 81, and 100 are all perfect squares, all right? So here's the list of the first 12 perfect squares, all right? You can see the square root of 1 is also technically a perfect square. All right, the 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, right? Those are your first 12 perfect squares, because when you take the square root of these numbers, they come out whole and even. All right, so when we're talking about simplifying radicals, we need to look for perfect square factors. All right, so here's like the key idea here to simplify radicals. All right, you must use this multiplication property of square roots to simplify radicals. All right, and what this multiplication property of square root says is that if we have the square root of some number, all right, we can break up that number into its factors. All right, so the square root of a times b is going to be equal to the square root of a times the square root of b, right? We can break up a radical into 2 separate radicals, all right? And we want this square root of a to be a perfect squared numbers, all right? So it has to be one of these factors here as for your perfect square to break up your square root into. All right, and the radicals only, a radical expression is in its simplest form if and only if there are no more perfect square factors inside the radical. All right, so now we're going to use this multiplication property on some examples here. All right, so again, directions are basic, right? It just simplify the following radicals. All right, and actually, probably should say completely simplify the following radicals. All right, so in example 4 here, we have the square root of 18. All right, so we want to break up the square root of 18 into 2 factors, and one of these factors needs to be a perfect square number. Okay, So we can automatically just kind of break up a radical into these two radicals, all right, using multiplication property of radicals, all right? And if I don't know what numbers to divide or break up 18 into, right, it can be one of two ways, right? We can use a factor chart to look at it, or we can just use a calculator, all right? We all have a calculator on our phone or on our computer right here, all right? So all we need is a basic calculator for these problems, all right? And you can see if you try to take the square root of 18, right, we get a decimal answer that is not what I want, all right? We need to simplify it with an exact answer, all right? So to do that, we're going to take that number 18, and we're simply going to divide it by one of these perfect square numbers here, all right? So one of these numbers in our squares here, these are our perfect square numbers. So we need to find which one of these factors can divide evenly into 18, all right? And we want to find the largest one that we can. So if I look at like 16 is already too big, it's not going to divide into 18. So then I want to look at the next one, which is 9. So 18 divided by 9 gives me 2. So there it is. All right, so 9 times 2 is 18. So that means I want to break up this rad 18 into the square root of 9 times the square root of 2, because this square root of 9 is a perfect square, and the square root of 9 is just 3. And this rad 2 just stays as a rad 2 because it is not a perfect square. So my simplified answer would be 3 rad 2. All right, and rad is just another word for the square root symbol here. All right, so example 5 is the same way, right? We want to simplify the square root of 50, which means we want to break up the square root of 50 into the square root of a perfect square factor times the square root of another factor. All right, so we have to take that number 50 and we got to divide it, all right, by one of our perfect square numbers. All right, so 50, right, 25, I think goes into 50. So let's see, 50 divided by 25 gives me 2. All right, so the square root of 50, I want to rewrite, I want to break up into the square root of 25 times the square root of 2. And I'm going to box up my 25 because that is my perfect square factor. So my square root of 25, right, is just 5. And this rad 2 just stays as a rad 2. So that is my simplified answer of 5 rad 2. All right, number 6 says we have the square root of 20. All right, so again, we need to break up the square root of 20 into two numbers. All right, well, I know 2 times 10 is 20. All right, you may think that, but the number 2 or the number 10 is not a perfect square, right? We need to divide this 20 by a perfect squared number, all right? It needs to be a factor of 20, one of these perfect squares, all right? And 16 is going to be too big. I know 9 doesn't go into 20, so I think it's going to be 4. Right, so 20 divided by 4 is 5, so yes. All right, so the factor pair that I want to use when I break up 20 is 4 and 5, because this square root of 4 is my perfect square. So my square root of 20, I'm going to break up into the square root of 4 times the square root of 5, right? Because 4 times 5 is 20, and this 4 is my perfect square factor. So now this square root of 4 simplifies as 2, and this rad 5 just stays as a rad 5. All right, so again, these are kind of the steps here. This is what I just kind of talked about and did the example problems as, right? So step 1, we want to break up the radical into the product of a perfect square and another factor using the multiplication property of square roots, right? So again, this is that square root of a equals the square root of a times b equals the square root of a times the square root of b, right? Where this square root of a, this is my perfect square factor. All right, and then step 2 is to simply take the square root of the perfect square and leave any numbers that are not perfect squares inside the radicals, all right? So any numbers that are not perfect squares, they just simply stay inside the radical. All right, so here we want to, again, do some practice problems together, all right? And then there'll be a practice worksheet for you to do after this. All right, so the directions say to simplify the following radicals by finding the perfect squares, all right? So again, here's a list of those perfect square factors, all right? You should see, you're going to see these numbers a lot, so hopefully you'll start picking up on what these numbers are, because they'll be all over the place, okay? So here we go. Example 7 is the square root of 8. All right, so again, we need to break up this square root of 8 into two numbers or two factors of 8. Right, one of these is the perfect square factor times this other factor, its other part here. All right, then we take that 8. Well, I know 4 times 2 is 8. So that means I'm going to take this rad 8 and I'm going to break it up into the rad 4 times a rad 2, because this is my perfect square right here. The square root of 4 turns into 2. Rad 2 is going to be my simplified answer. All right, number 8 is the square root of 32. All right, so actually with 32, there are two perfect square factors of 32. All right, because 4 times 8 is 32. All right, so I could do that route. However, there is another perfect square factor of 32. All right, and to make it easier on yourselves, you always want to try to find the perfect or the largest perfect square factor when you're simplifying radicals. All right, so again, you want to find the largest perfect square factor when you're simplifying radicals. All right, and the easiest and the best way to do this is just by simply dividing. All right, so you're going to start with that number 32, and then you're just going to simply divide. All right, go down the line here, right? Start with the largest perfect number, perfect square factor that can go into 32, and just kind of work down the line here. All right, so 25 would not divide evenly in 32, so I'm going to try the next one down, which is 16. All right, and 32 divided by 16 is 2. All right, so that means the square root of 32, I really want to break up into the square root of 16 times the square root of 2, because the square root of 16 is going to be the largest perfect square factor. All right, the square root of 16 is 4, so you get 4 rad 2. All right, I could break up that 32 into 4 times 8, but then I would have to keep simplifying, and it's going to involve some more steps here. All right, so to avoid all those extra steps, we want to try to find the largest perfect square factor first. All right, so number 9, we have the square root of 27. All right, so I want to break up this 27 again into two factors. All right, so I'm going to take that number 27, punch that into my calculator, and I'm just going to start dividing it by some of these numbers, okay, to see which one of these numbers can divide evenly into 27, and that's what I want to break up 27 into. All right, well, 16 is, I don't think is going to divide evenly into 27, so then my next number to try is 9, so 16 divided by 9 is 3. Oh yeah, that's right, 9 times 3 is 27. All right, that means my square root of 9, I want to break up, sorry, square root of 27, I'm going to break up into the square root of 9 times the square root of 3, because this square root of 9 is my perfect square factor of 27. So now this turns into a 3, and this rad 3 just stays at rad 3, and your simplified answer is 3 root 3, or 3 rad 3. All right, we got a couple more here. All right, and then it'll be time for you guys to do some practice. All right, so on number 10, we have the square root of 60. All right, and actually, why don't we pause the video? All right, I want you to find the two factors that you're going to break up the square root of 60 into. All right, so what are my two numbers that I'm going to break up 60 into? So go ahead and pause that video and answer that question. All right, let's see what we did here, okay? So hopefully you took 60 into your calculator and you just started dividing down the line here, right? Well, 64 is too big. 49, I don't think is gonna go evenly into 60. So maybe we start trying with 36, right? So 60 divided by 36, nope, that's not gonna be it. So then I try the next number down from 36 is 25. Well, I know 25 doesn't go into 60. So then I'm going to try the number 16. Well, 60 divided by 16, ooh, 3.75. Nope, that's not going to work because that's not a whole number. So next number to try is 9. So 60 divided by 9 is 6.6. Nope, that's not going to work. So how about that number 4? 60 divided by 4. 15. There it is. All right, so those are my two factors that I'm going to break up 60 into. So hopefully you found that 4 and 15, right? The square root of 4 times the square root of 15 gives me that square root of 60. All right, and I want to pick 4 and 15 because 4 is my perfect square factor of 60. Right? And the square root of 4 turns into just 2, and this rad 15 or square root of 15 just stays as such because rad 15 cannot simplify anymore. So your final answer is going to be 2 rad 15. All right, let's see, number 11, right, we have the square root of 48. All right, so again, I'm going to break up this rad 48 into two numbers. All right, and to find out what those numbers are, all right, again, we're just going to start dividing. All right, so we take that 48, and we're going to start dividing down the line here. All right, well, I'm not going to start with 49 because 49 is too big. All right, and 36 is probably not going to work. That's too big also. I know 25 doesn't go into it. So the next logical one to try is 16. All right, so then we take 48 and we divide it by 16 and see if this comes out evenly. And it sure does, right? So 48 divided by 16 is 3. So that means I want to break up the square root of 48 into the square root of 16 times the square root of 3. And the square root of 16 is going to simplify down to 4. So my final answer is 4 rad 3. All right. So again, the square root of 48, there is actually another perfect square factor that divides evenly into 48. All right, and that number is 4. But I don't want to use 4 because I'm going to have to do extra steps if I first broke up 48 into 4 and 12. All right, so you really want to find the largest perfect square factor first. All right, and that'll make you have less steps to do. All right, we got one more to try here. All right, number 12 is the square root of 98. All right, so again, I need to break up this 98 into two numbers. All right, so now I got to try to see what numbers divide evenly into 98, right? But again, it can't be just any random number. It needs to be a perfect square number. All right, so I'm going to take 98, and I'm going to start up high and kind of work down low, low, low. All right, well, 81 is going to be too big. Maybe 64 I'll try. So 98 divided by 64. Nope, that's not even. So the next one to try is 49. And 98 divided by 49 is 2. Oh, there we go. So that means the square root of 98, I want to break up into the square root of 49 times the square root of 2. And my square root of 49 is going to simplify into 7. So that means my final simplified answer is 7 rad 2. All right, so hopefully this started to make a little sense here. If it doesn't, or you're still kind of lost, all right, please email me and let me know, and I'll get back to you. And also, please try to make the Google Meet session on Friday at 10:30 so we can kind of review this along with some of the new stuff that we're going to learn on Friday. All right.